right? So we have heart rate, plus we have the stroke volume, okay, how hard the heart beats to move the blood, okay, and also how fast the heart is beating. Those two things in combination with each other is going to give you cardiac output, and that is the true measure of how strong the heart is. Now, if we took you into a lab and clinically tested you, okay, with an echocardiogram or an ECG or an EKG, it's really ECG, but everybody says EKG, we would be able to detect stroke volume and be able to factor that in. But you know, we are not doing clinical tests on people, we are doing field testing. So the only thing we can use is heartbeat or heart rate. Okay, we're not able to detect stroke volume. Okay, so heart rate and heart rate reserve. So this information is also in your ACSM textbook and to some degree in your NASM textbook as well. But I think your go-to is a pretty solid ACSM on this. Okay, so it says when an actual measured maximal heart rate taken during a graded exercise test is unavailable, the personal trainer commonly uses an age-predicted estimate, 220 minus the age. Be aware that there are some controversies over using this method to estimate maximal heart rate. The concern with this method is the wide range of heart rate variability for a given single age. So it's plus or minus 10 to 12 beats per minute. So if my maximal age predicted heart rate, let's say I was 20 years old, 220 minus my age gives me an even 200, right? So plus or minus variability means that my maximal heart rate could be all the way up as high as 210 beats per minute or lower down to 190 beats per minute, which is a huge variance. That's like, that hits the side of the barn, but that comes nowhere near the dartboard hanging on the side of the barn, right? You know, you can hit the side of the barn with this, but it's not really all that accurate. But it gives you a bare minimum idea, okay? So it says here, thus, a 20-year-old may not have a maximal heart rate of 200 as predicted by the formula, but instead her estimate could be as low as 188 or as high as 212. Okay, if we use the 12 plus or minus 12 beats per minute. Now, that being said, this is still the most common formula that's used. Heart rate reserve, okay, it's also called the Carbonin method. Take a look here, Carbonin method is a difference between maximal heart rate and resting heart rate, multiplied by your desired intensity, and then you add the resting heart rate back in. So here's your formula up here. Okay. Jack is 37 and has a resting heart rate of 55 beats per minute. What is 75% of his maximum heart rate reserve? Maximum heart rate. Sorry. Did heart rate first, okay, and then heart rate reserve is second. You have to find out what their maximum heart rate is, age predicted, in order to do heart rate reserve method. Okay, so what is 75% of Jack's maximum heart rate? You take 220 minus his age, which is 37, okay, and then you multiply that by 0.75. So that gives it
137.
Yes. So you do the parentheses first. So 220 minus 37 gives you, I don't know off the top of my head, and then you multiply that by 0.75. So at age 37, 75% of his maximal heart rate is 137. Now, if you do the heart rate reserve, again, if you take a look at this white formula up here, the formula in white, you've got this heart rate max, which is 220 minus your age. Then you subtract the resting heart rate, okay? And then you multiply the desired intensity, and then you add back the resting heart rate again. So in this example, and Jack's resting heart rate is 55 beats per minute. So what is 75% of his heart rate reserve? So we take 220 minus his age, okay? Then we subtract 55 for his resting heart rate, which gives us 128. Then we multiply 128 by 0.75 because we're looking for 75%, so multiply by 0.75. That gives us 96. And then we add back the resting heart rate in again. And then that gives us 151 beats per minute for his heart rate reserve. 75% of his heart rate reserve is 151 beats per minute. But there's his age predicted 75%. That's a 137. That's a pretty big difference, right? His age predicted heart rate max at 75%. 75% of his age predicted heart rate max is 137. But 75% of his heart rate reserve, when you account for resting heart rate in there, is much higher. It's 151. They don't coincide. It's apples to oranges on this. Okay, so don't try and figure out like how that jives together. It just doesn't. Let me show you guys right here.
So would we use all of these all the time, or are there some that we can omit?
Good question. So the answer is on these two formulas, yes, you're going to want to be aware and familiar with using them both. And in the question that Bethany had, she's got a friend that has chronic high blood pressure, hereditary based, so she's not eating salt and vinegar potato chips and French fries all the time, right? She's actually got something hereditary where there's high blood pressure, okay? That would be an area where the Carvonin method, the heart rate reserve method, would come into play there, because she would have naturally a high resting heart rate. So you would know that you could take her past, a typical limit that would be age predicted, because she's got a higher resting heart rate, okay? It would still freak me out, because if she has a blood pressure of above 140 milligrams of mercury, if her BP or blood pressure is higher than 140, I would want a doctor to sign off on it. That's the area there where you need to have a doctor say, okay, she's all right to train. Because if you go and train her and you know that she's got high blood pressure and she goes and has a stroke, right? High pressure on the arterial walls, that's what blood pressure is. And if something bursts in the brain, something bursts in a coronary artery, something bursts in the body somewhere, internal bleeding, that's on you, right? So it could be gross negligence or negligence, okay? And you could get sued for that. So you want the doctor to say, yes, I know that Bethany's friend has high blood pressure. I'm giving her the green light though for exercise. You're in the clear. Or he might say, don't take her above a heart rate of such and such. Or he might say, don't take her above a certain metabolic equivalent, or MET. Doctors will use METs sometimes. We're not going there today. But
and you said it was 140 for the mercury? For what again?
Oh, yeah. So when you take...
so if I talk to her, tell her she needs to go get that checked out, because I think she just knows she has it. It's been tested once, but it's been like a long time, and she just has never really done anything about it. So,
do you know if she does endurance stuff? on a regular basis?
Her and I run half marathons together, so we run quite often, but I don't know if that's really endurance. I mean, that's
Yeah.
longer endurance, but it's not
Yeah, that's endurance.
short. And I know the boot camp they've been doing where she makes them do like sprints and stuff where they have to, for like 2 miles straight, they like walk 100, jog 100, sprint 100, walk, and they do that for 2 miles, and then they'll do burpees in the stadium. Because we live in a small town, we don't have a gym, so we, that we can just go to. So we use a lot of things like the track or the football field, stadium seating. So she is doing stuff like that, but
Yeah, I would have her go and get a physical.
okay.
I would suggest that she go get a physical and have the doc check her blood pressure, check her heart rate, and have her talk to the doc and say, hey, boot camp instructor, I run half marathons on a regular basis. Cardio is nothing new to me, but still got high BP. So what's up? Right? And you might check into that a little bit deeper. But you would use the heart rate reserve method on her. Let me show you why. Okay. So how old is your friend? Just to make this a little bit more interesting.
She's 37.
She's 37. So she's a dusty old uterus now.
She just had a baby last year. She's got a 1-year-old. Be nice.
I'm just kidding. I'm joking.
I'm 36. You're not being very nice. It makes me feel bad.
So let's say the person's heart rate is in really great shape. Okay, so let's say they've got a heart rate of 50 beats per minute, which that's a good resting heart rate. Now this column here, this is just those formulas. Okay, if you take this right here, this formula is just, it's oh, I'm sorry, this here, right here, this is just 220 minus the person's age. So 220 here minus that number right in there. That's what that, or this 37. So 220 minus 37 gives you the sum right here, okay, of 174. Okay, that would be 95% of the person's maximum heart rate. So this column right here is just those formulas. Okay, what is 95% of the person's maximal heart rate? 174. What is 85% of their maximal heart rate? 156. Okay, what is 65%? By the way, these are your zones, right? So you've got zone 1 down here, 50 to 65% intensity. Then you got zone 2, 70 to 85%. Zone 3, where you're cranking hard. Typically, when you get above 85% of a person's maximal heart rate, you as a coach can with a lot of confidence assume that they will not be able to sustain that intensity for more than a short period of time. Okay? They are going to have to slow down and pace themselves. Okay? Because as soon as you go above 85% of your heart rate's intensity, okay, your body is not able to produce energy fast enough to sustain that high output, that high energy demand, and you will slow it down. Okay, so now that 85% could mean a really, really high heart rate or a really, really low heart rate for that particular person, depending on their age. Okay, so 85% is where we get into zone 3. Now, this is the Carbonin method here, this column. Are you guys seeing me highlight this stuff right here? Do you see how advantageous it is to have this stuff all plugged into an Excel formula? Because all I would need to do if I was training that boot camp gal is have this on my phone and say, okay, let's see what you're able to do at this heart rate and see how it goes, right? So let's say their resting heart rate is low, age 37, resting heart rate is low. If you take a look right here, this is the Carbonin formula right here that I just went and put into Excel. Okay, so their low point, 65% intensity, would be 136 beats per minute compared to the guesswork of 119. Okay, because maximum heart rate takes 220 minus your age. It doesn't even ask you whether you're male or female, whether you're in shape or not in good shape. Doesn't, it's just blanket. How old are you, right? This here takes in your resting heart rate, which is a good data point because that says a lot about you, what your heart rate is doing at a resting level, okay? How strong it is. So that person, you can take them to 136 beats per minute and they're still in zone 1. So that would be, that's a good example of how effective the Carbonin method is there for you, Brian. Now, taking them up to 85% intensity would be 163 beats per minute in comparison to 156 beats per minute. So a whole, almost 10 beats higher. Now, if your friend, did you say she had 77 beats per minute for resting heart rate?
Her average, we did that, her average was 79. Like, the first time we did it was 78. The second day, it was 81. Day 3, it was 77. And I had her do it at work because she sits all day long. She's an accountant. And so I'd had her do it, when she hadn't been moving at all. And that's how high it is, just sitting there.
Yeah, okay. Yeah. No coffee?
Oh, God, no. She drinks a lot of coffee.
Oh, okay. That's totally different. Yeah, so she needs to take her resting heart rate. That's good. That's good. I was worried there.
I think she drinks between the time she gets there 6:30, 7 o'clock in the morning until noon. She has about 3 cups, but not like coffee cup, like a regular drinking glass, worth just like a coffee mug.
Starbucks?
No, just out of the pot, black.
Yeah, so what she needs to do, you need to text her after class and say, tomorrow when you get up tomorrow before you roll out of bed, before you drink your coffee, see what your resting heart rate is. Just look at your watch or your alarm clock or whatever and just do a 60-second pulse check and see what her heart rate. I'd be really interested. I'll bet you it's lower. It's the coffee. It's the coffee. The caffeine, bam. So this is your heart rate reserve. Now for her, if her resting heart rate was a true 79 beats per minute, okay, notice how her heart rate reserve is going to be different because it's factoring in already a predisposition for a high heart rate. So her 85% is going to be 167. Her 65% in zone 1 is going to be 147. Okay. So it'll be different based on heart rate reserve. So heart rate reserve is considered a much better standard for a heart rate for programming. Now the reason why we went into this today on programming is because we need to know what to do with this heart rate, these answers, to these tests, right? So if we're taking a person's heart rate, we need to have an idea of where to program them. Or if we're taking a person's VO2, we need to have an idea of what that VO2 means, okay? Now with the VO2, you can go to these charts. Here we go for our VO2 charts, right? So when we did the Rockport walk test on that person, and what did we get? We got 54.
54.22.
For the step test, right?
52.
And for the walk test, we got 45, right? So we would go here to for women, and then we also have for men. So it was Candy Apple that had the 52 for her, and how old was she? Candy Apple didn't say how old she was. Okay, it's just an exercise in doing the equation. But let's say she's between 26 and 30. She has a 52. She's in good physical condition. Okay, so she's in the good category. So And NASM tells you, points you in the direction of like zone 2. Zone 2, potentially zone 3. We'll talk about that next class because we're at time right now. But for men, a 45, I think was 45 for the Rockport walk test. Was that the answer we got for that? So for me, being 43 at the time, and that was, I just made that stuff up. That wasn't a true test. For a 45, that puts me in the 75th percentile on percent ranking according to our categories here in the United States. 45th, 45 would be my VO2, volume of oxygen capacity, submaximal estimate. Okay. Now you can also use this chart for doing the 1.5 mile test. Okay. And what the 1.5 mile test it does is it goes and it equates your time and gives you a score based on your time for a VO2, and I think gives you the formula for that there. So your VO2 is, there's your equation. Okay, same thing, putting the seconds into decimals. But this is a very accurate test. Okay. Now, before I let you guys go, we're going to go into the zone 1, zone 2, and zone 3 training. Like I'm trying to get there. Okay, and you need to know this. Okay. Before I let you guys go, here's the interesting thing. I have done both the Rockport walk test and the step test on the same day, and I get different VO2 scores for them. I've done the YMCA step test and I've done the Queens College step test and got different VO2s for it. Done the formulas and got different VO2s. So does that piss me off? Yeah. What that means is the tests don't intercoordinate, right? So when you do the YMCA step test, you got to do the pre-test and the post-test YMCA, right? And it's a submaximal estimate of your VO2. But most importantly, it gives you a data point pre and post. When you started and you did the YMCA step test, your VO2 score was in the average category and it was a 32. When you finished working out with me after 6 months, your VO2 was in the excellent category and you were 52 on your VO2 score. That's what we're showing pre and post with the YMCA. Okay, does that make sense to you guys? So that's the most important thing. But monkeys like shiny things, right? We like things with bells and whistles and stuff like that. So they like to be able to take their score and say, yeah, well, okay, based according to everybody else in the US, I rank, in the 95th percentile. I'm in really great shape. That's good. That's an achievement. They feel good about that. So that's something that you can boost their confidence with, or if it's a bad score, you're like, here's our starting point, but you know what? The next time we take this test, you're going to see, boom, you're way above that, and that's going to feel really good. So the different tests will give you different VO2 scores because they all are an estimate of your submaximal. The gold one that I really like out here as far as a field test is if they're in shape enough to do the 1.5 mile test. That's one that I'll do. And that's one that I do on myself. Okay? And man, I just start, my palms start to sweat just thinking about that 1.5 mile test because that's a race as hard as you can go, man. So if you haven't done the 1.5 mile test and you feel like you're in condition to do it, you got to do that. Because I swear I'm in better shape now than I was when I was 25, but I can't prove it because I don't have any of that data. I never wrote any of my stuff down back then.